So you just watched a video that's talking about completing the square. So you were completing the square and rewriting into perfect square binomials. This video is going to talk about how we can convert to vertex form, which we saw in class today, when it's not a blank for the C part. Okay, so far we've only looked at when we don't know what C is. We're trying to figure out what it should be to make a perfect square binomial. In this case, we're already going to have a number there, and we're going to have to figure out what it's going to be. All right, so what we're going to look at first is look at an example. Okay, we'll look at a couple examples and try to generalize from there. All right, so when we're converting to vertex form, we want to take something that looks maybe like this, and we want to get it to look like this. Okay, now we've not talked about this form exactly, but when we think back to before fall break, we talked about transformations. Okay, so this h here, if it's inside with our x's, how is that changing our function? We have this k outside our x, and it's being added. Okay, it could be subtracted as well. It's being added. How is that going to affect our function? All right, so answer these couple questions about those transformations. So this minus h, that tells us that we're going to be moving in the x direction, so left or right. This minus specifically says we're going to move right. Plus k, since it's outside the x's, it says we're going to go in the y direction, specifically with the plus. That means we're going to go up. Okay, so we want to get the standard form to look something like this called vertex form. Okay, and we'll learn more about vertex form later. So what we want to do first is try to get to a point where we can find C. Okay. Now, we want to write out the steps here. So step 1, include blanks to find C. So now look at this. If I cover this up, this part up, we are completing the square. We're trying to find C. So we know that, let's take first off, B is going to be what? B equals 4, which means that C equals 4 over 2 squared, which equals 4. So we have plus 4. Now if we have plus 4 here, what do we have to do on the other side? Minus 4. Okay? Minus 4 on the other side. Now, our second step, we want to group the perfect square. Okay, so I'm going to rewrite this the exact same way that we just saw it. And I'm going to group my perfect square. Okay, this is what we could move earlier when we completed the square. X squared plus 4x plus 4. We have B is 4. We know that C has to be 4 as well. And we can rewrite this as a perfect square binomial. Okay, so step 3, rewrite as perfect square. We're out of room over here. There we go. Perfect square binomial. And simplify. Okay, so if we've got x squared plus 4x plus 4, we now write as x plus 2 squared minus 9. Okay, so this can be a bit tricky. All right, now when we did this in class, we didn't do all of these steps. We did it more with the algebra tiles. All right, so the algebra tiles work just as well, and we'll take a look at one of those next, but I do want us to be familiar with the steps. Okay, and we're going to talk about the steps more in class as well, but this is the basics of what we're doing with our steps. So let's look at another example. Okay, and I'm going to go ahead and, I don't have algebra tiles right now, but we'll go ahead and draw some out. Okay. Okay, so there's my attempt at a grid. So we've got, let's say we have x squared, go minus, no, we'll go plus 6x plus 2. Okay, so I'm going to go ahead and shade in everything that we have. We have an x squared here. We have 3 x's on this side, 3 x's on this side, and only 2 little 1 tiles here. Now, I know that this whole square is going to have the side length of x 1, 1, 1, so that will be x plus 3. This side will be x 1, 1, 1, x plus 3. So I have x plus 3 squared. Now, in our task in class, we talked about, do we need extra tiles? So do we have to borrow them, or did we have extra tiles left over? So in this case, we still need to fill in this box, this box, this box, and then these 4 other ones. So we're missing 7 tiles. So this one right here, whole square. Okay, that's representing the whole square, this whole space here. But we're missing 7 tiles, okay? So we have to write down a minus 7, and this represents the tiles missing from the square. Okay, so this method you might see as easier because all we had to do is draw our picture to see what was going to go inside our parentheses and what's going to go outside our parentheses. That is fine. If you would like to draw a picture, that's a good way. That tells them that you understand what's going on visually, and you're making those connections visually as well as algebraically. All right, so I'm going to go ahead and walk through one more using the other form, the other steps that we had, and then I'll have you do a couple questions on your own. So let's take a look at one last problem. X squared minus 8x plus 4. Okay, so I'm going to go ahead and put in my blanks. Plus blank, plus 4 minus blank. If we add something, we have to take it out as well, because that's going to make 0. Now I know b equals what? Negative 8. So c equals negative 8 over 2 squared, which equals 16. So if I add 16, I have to subtract 16. So I'm going to group my perfect square binomial together. Now, I know that b is negative 8. So I need to do plus negative 8 over 2 squared. And then I'll combine these terms here to get negative 12. Nope. All right, so I'll go back here since I lost some screen. So I grouped my x squared minus 8x plus 16 because that's my perfect square that I made. And then using our formula from before, x plus b over 2, the quantity squared. And then we combined our 4 and negative 16. So we simplify to get x minus 4 squared minus 12. And we'll talk more about what that means next week. All right, so I've got a few questions for you to answer to see how we're doing. All right.